Okay, so here is the explanation of the periodic table, alien periodic table answer key. So let's start with clue number one. The inert unreactive gases, which are the noble gases, are BO, WO, J, and L. So let's put those over here. BO, J, move this over just a little bit. L, and WO. All right. And then it says BO is a noble gas but does not have 8 valence electrons. The only noble gas without 8 valence electrons would be helium, which is the very top of that column. So that's BO, the noble gas. We already have it there. And then it says L has its outermost electrons in the second energy level, which means that L belongs in the second row. So if we put the row numbers here, these are the energy levels. So L actually belongs in the second row. So I'm going to rearrange those for the moment. And WO, wobble, has the highest atomic mass. So that means wobble belongs at the bottom, which is where it is. And the only space left is J in the third row. So this is the column with the noble gases. And we have finished that first clue. I'm going to cross that off. All right, so that one's taken care of. Then it says that the alkali metals are X, By, Ch, and Q. All right, so okay, so we're done with that first clue. The second clue says that the alkali metals are X, By, Ch, and Q. So By, Ch, Q. What did I miss? X. Okay, and actually I just made a quick mistake there. The top element in that column is hydrogen, which is not an alkali metal. So that's one of the important things is when you're doing alkali metals, you have to remember that hydrogen at the top is not an alkali metal. So leave that space blank for now. So these four elements are the alkali metals. And it says CH has the lowest atomic mass. Remember, atomic mass, the elements get bigger as you go down the rows. So the lowest atomic mass would be the one at the top. And we have CH at the top. And Q, or Quaxel, is in the same period as Wobble. Okay, so Wobble is in the fourth row. So I'm going to switch these around to make Q in the same row as Wobble. All right, and that's all it tells us for now. So I'm not sure if those last two are in the right places, but I know they're in the right column. All right, the halogens are A, V, KT, and KT. Sorry, there's only three of them. So let's find V, A, and KT. All right, and it says V is in the same period as Quaxel and Wobble. So I'm going to switch these around for now. Okay, so I know V is in the right place. And I know that the other two are in the right column, even if they might not be in the right row. So I'm going to go ahead and kind of highlight. So I know that this one is in the right place. I know that this one is in the right place. We know that all four of these are correct. And I know that this one for sure is correct. Okay, so these other ones I may have to rearrange as we go along and find the other clues. Okay, so the metalloids are E, HI, T, and SS. HI and T are in group 14, so that's an important factor. So because the metalloids are a little bit tricky in terms of their place, but they go from group 13. So let's it says HI and T belong in group 14. E, the metalloids are this zigzag. SS would go here, or that is a metalloid, I should say. And then it says YZ is a metalloid by location, but has properties of a metal. So the one that's kind of, if you look at this staircase going down, the one that doesn't quite fit is aluminum, which is this element right here. So I'm going to put YZ there, and I'm going to mark that as being in the right spot, and then I'm going to look at the rest. SS is the highest atomic mass of the metalloid, so that is the one that belongs, the farthest down, so that's good. And then it says T has more protons than HI, so T has to be farther down. Okay, so that looks correct to me. And then the only other metalloid is this one, so the only spot it could be was there. The most metallic element on the planet is X. Okay, so the most metallic, if you look at the diagram and the trends, elements get more metallic to the left and they get more metallic to the bottom. So the most metallic element would be the one in the bottom left corner. So I'm actually going to switch these around. So now I know that this is in the right place. And since the only other alkali metal is By, and that's the only spot left, I now know that that's locked in the right place. Okay, and then it says the most chemically active non-metal is A. So nonmetals are the upper right-hand corner. The noble gases are not reactive. So we kind of, when we're talking about reactivity, we sort of chop off that last column because they're not reactive. So if you're talking about the most reactive column on the right, it's group 17, the halogens. And the most reactive of those elements is fluorine. So I'm going to switch around A and KT. So it's in the opposite of the metals. Okay, so now I know that A is in the right place. It's the most reactive nonmetal. And that means that since this is the only halogen left, and they told us that KT was a halogen, that is now in the right place. So we've got all the ones on here so far are kind of locked in. And it also told us it has 9 protons. Whoops. So the 9 protons means it's the 9th element. And if you count across, that's element number 9 for A. The lightest element is PF. The lightest element is hydrogen, the very first element on the table. So that tells us we can put that in and we can lock that in. And the heaviest is El Rado, which is El. The heaviest would be the last one. So that's right there, and we know that that is correct because that's the only possible place the heaviest element could be. All right, so again, everything we have on here so far, based on the information we have, there's no other way for it to be arranged, so we can lock all those in and go on to the second page here. Okay, now, the chemical makeup of the planet's oceans, so we're talking about water, has about the same makeup as Earth's, which means ocean water is salt water. So we've got H2O and NaCl. So it says when you boil off the liquid, it has 2 atoms of PF, which would be 2 hydrogen. We already have PF in place, so that's good. And 1 atom of Nu. Nu has to be oxygen since water is H2O everywhere in the universe. So that means that Nu belongs in the place where oxygen goes. And that's oxygen spot. That's the only possible answer there, so I'm going to lock that in. And then what's left behind when you boil salt water is salt, which is Na and Cl. So it says it's made of By and Kt. Well, By we already know is the alkali metal in the third row, which is sodium. That means that Kt is chlorine, which is in group 17. It's one of the halogens. We actually already have that in place. Okay, so we know that that's right. We're confirming that that's in the right spot. The element doggone, D, has 4 protons. So that means it's element number 4, which is 1, 2, 3, 4. That's element number 4. 4 protons means element number 4. It can't be any other element. That's locked in. All right. Floxit FX is a black crystal with 4 protons. 4 protons means group 14. There's only one spot left in group 14. Oops. And that is the very first one, which is the place where carbon would go. Carbon is a black crystal. So there we go. That's all set. Both R and DO have 4 energy levels. So that means they're going to be in the 4th row. So I'm going to put them in here, R and DO, in the 4th row. I know there's another spot over there, so I may, either one of these could be over there. But let's look at the rest of the clue. It says R is less metallic, so these need to be in the reverse order here, left to right, because more metallic is on the left, less metallic is on the right. So again, R could be here or here, so I'm not going to lock that in yet. And if R is here, then DO could be here. So I'm not going to say these are definite yet, but they have to be in the 4th row. And it says M, G, and SS are all in group 15. Well, we already have SS in group 15. Hey. How are you? Oh, I totally get it. Well, you do you. Okay, so it says M, G, and SS are all in group 15. All right, we already have SS in group 15. And since it's a metalloid, we know it's going to be down there at the bottom because that's where the staircase of the metalloids go. So there's 2 spots left for M and G. M and G, we know they're in group 15. And it says G has fewer total electrons, which means it's a smaller element, smaller atomic number, than M. Well, G being a smaller element would mean it's on the top, so that is already arranged in the right order. Those three elements in group 15, there's only 3 spots, and since G has to be above M, and we know SS is at the bottom, those are locked in, nowhere else to go. Okay, UP, OZ, and NU all gain 2 electrons. Well, we already know NU is oxygen, and it's in group 16. Group 16 has 6 valence electrons, which means it needs 2 more to get to 8. That's why it forms a -2 ion. And it says NU, we need to breathe. We know it's oxygen because of the clue about water. OZ has a lower atomic number than UP. So OZ is in group 16 with NU and UP, and OZ has a lower atomic number, so it's going to be the first element in the column compared to UP. All right, so we're done with that. We're done with that. All right, so we only have a couple left, which, by the way, putting UP in that group means there's only 2 spots left in row 4, and we know that DO and R had to be in row 4, and we know that DO had to be the left because it's more metallic. So there's no other way for those to be placed now that we filled in that last spot. So now we know that those are where they're going to be. We don't have to think about moving them again. All right, last one. A tends to lose 3 electrons. Z and Pi both lose 2 electrons. Okay, Pi loses 2 electrons from its 5th energy level. So that means it's in the 5th row. If it has a 5th energy level, it has to be in the 5th row. And for 2 electrons, 2 valence electrons, that means it's in group 2. And Z also has 2 valence electrons. It loses 2. AN, it said loses 3, which means it's in group 13 with 3 valence electrons. Okay, so now if I erase all the extraneous stuff here, we have all of our elements based on the clues in the correct locations as it was posted in the screenshot, but that gives you the explanation of why and how to figure out where all those elements go, which is similar to the new assignment, the the Kid Brother periodic table, and I'll post the answer key for that shortly as well. So just want to finish erasing all these out so you can see it clearly. But again, the screenshot shows this as well. All right, here we go. Last couple little lines here. And there you go. There's the clean version of the finished product with all the elements in the right places and the explanation for why they are the way they are.